Okay, so hello and welcome to this video tutorial for RC Hibbeler's Engineering Mechanics Statics textbook. So we have this problem from chapter 2 here that says express the force as a Cartesian vector. This problem is very similar to F2-21, so I'd suggest having a look at my tutorial for that problem if there are some concepts here that get lost on you, which I doubt it, to be honest, at this stage. So again, we have two different things here, right? We have this kind of A, B position vector idea, and we have this force F. They're not the same thing, but they are acting in the same direction. They are in line with each other. So we might start off by trying to understand the direction of AB here. So let's just determine its component. Once I've plugged in my thing, right? So we can say AB x is equal to, in this case, looks like it's acting 2 and then 2 again, so that's minus 4 because it's acting in the negative direction. AB y, looks like it's acting 7 across, and AB z looks like it's acting 4 down, so that's minus 4. Okay, we might want to then describe the direction of AB in terms of these coordinate direction angles here, alpha, beta, and theta, alpha, beta, and gamma, sorry. So here we could say the cos of alpha is equal to ABX over AB, or at least the magnitude of AB. Therefore, alpha equals the inverse cos of minus 4 over, and we need the magnitude here. So let's calculate that. Where should I calculate? Let's calculate it here. So I can say AB is equal to the square root of 4 squared plus 7 squared plus 4 squared, which when I bung in my calculator gives me a value of 49. Okay, so this is going to be 49. I can say beta is equal to the inverse cos of 7 over 49, and gamma can be taken as equal to the inverse cos of minus 4 over 49, so it's going to take the same value as alpha. Okay, so these values for alpha, beta, and gamma are the same as that for F. We can kind of reuse this idea here to solve for the x, y, and z components of F. And taking note of this idea here, we understand that when we take the cost of an inverse cost of a thing, we're just left with that thing because the cost functions effectively cancel here. So if the cos of alpha is equal to the x component of f over f, then we can say that the x component of f is equal to f, which from our diagram we can see is 900 times the cos of the inverse cos of minus 4 over 49. So we can just kind of cancel those cost functions and say put our minus 4 over 49 in here. And when we bung that into our calculator, we get a value of minus 73.7. For the y component, we can use the exact same process, 900 times 7 over 49, which is equal to 128.4. And the z component, we know the z component takes the same value as the x component because the alpha and the gamma angles are the same here, so we can say it's equal to minus 73.7. Again, just to save a bit of time. Okay, I'm just going to underline these in red. So the question's asking, express the force as a Cartesian vector. All that's left to do really here is to write force F out as a vector now. So I'm just going to do it over here. We can say force F, underbar to show this as a vector, is equal to minus 73.7I plus 128.4J minus 73.7K. And there we have our solution. So if you have any questions or comments about that problem, please feel free to leave them down in the comment section below. Otherwise, thank you very much for watching.